Hello everyone. In this lecture we shall discuss the Newton's forward interpolation. Here you have the equispaced nodes. If we recall our previous lectures where we have seen, you see, in this case the gap between x0 and x1 is same, x1 and x2. If it is h, it is also h, it is also h, okay, means it is a equispaced data. If it is a equispaced nodes are given, then we use Newton's forward interpolation and Newton backward interpolation. Okay, but in the previous lecture we have seen that this gap was unequal. That's why it was an unequispaced case, right? So now for equispaced nodes, the interpolation is based on the finite difference operators, okay, such as your forward operator is delta, inverted delta for your backward operator, and central operator is small delta, likewise. And actually these operators are originated by James Gregory, okay. So now the interpolation based on the Newton's interpolation, now combining this operator, we call, sometimes it is called as the Newton's Gregory forward interpolation, okay, or simply the Newton's interpolation, right? So before the details of the discussion, let me to introduce myself, Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so now without much delay, let me to tell you the different methods available for your Newton's forward interpolation, right? So now here you see this, I can write the nodes as like this: xi is x0 plus ih. If I write x2, means it will be, you see, x0 plus 2h, is not it? It is x0 plus 2h. Similarly, if I write x3, it will be x3 plus 3h. So this is what this meaning of this equispaced nodes, okay. So for basically for equispaced data, we use the following interpolation formula. One is the Newton's Gregory, or simply the Newton's forward interpolation, or sometimes we call it NFI, or we call it Newton's forward interpolation formula, right? So now basically you see, if the polynomial is asked at the beginning, this is the beginning of the node. If it is asked at the beginning of the node, means very close to the x0, means it may be to some left of x0. If it is left of x0, it is called your extrapolation, okay, or it is near x0, then towards little left or towards little right, okay. So use this interpolation formula near x0, and near x0 means beginning of the table, and extrapolates a little left of x0. Now if it is asked to find the polynomial close to the final point, right, then we use your backward interpolation, right? Gregory-Newton's backward interpolation, NBI, Newton's backward interpolation, or I will call it Newton backward interpolation formula. Shortly I will going to derive it. So you use this interpolation if the polynomial it is being asked, it is near the end point, okay, and extrapolates a little ahead of xn. Suppose it is beyond xn here, then we can also use the backward interpolation. Now if it is at the center of the table, okay, now if it is at the center, suppose it is asked to find a polynomial at the center of the table, right? It's at the center of the table. So then what will happen? We can use the Stirling central difference formula, right, or the basal central difference formula. Again, there are two aspects here, okay. Now if these points are even number of nodes are there, then there will be two midpoints, is not it? There will be two midpoints, two central values, two midpoints. Suppose you say these are the two midpoints here, okay. Now if the midpoint so in case of two midpoints, okay, while we use the formula, we will use the second midpoint for Stirling central difference formula, and if we are using Basel's formula, then we are using this first one out of these two midpoints. That means here you see, that means in Newton forward, while we use the formula, we will use x0, right? X0 will play the key role here, and while we use the backward, and here xn will play the key role. Okay, so likewise while we use the Stirling central difference formula, then here the out of if two midpoints at all, if one midpoint then fine, if two then we use the second of these two midpoints. Similarly for your central we use the first of the two midpoints. Okay, means however we can use any of the interpolation, but to minimize the error, to get the best approximation out of this, these are the technique to choose the formula. However we can choose any of the formula we like. So without much delay, let us now derive the interpolation formula. So now let us derive the formula for Newton's forward interpolation. Okay, NFIF, Newton's forward interpolation formula. So here you see we are given a tabulated data like this. Okay, we are given a tabulated data. This xi here is a central value, but while working on this we have to concentrate on the initial point here for forward. Okay, so now this is n plus 1 nodes are given, so consider a polynomial of degree n. Let me derive the formula. Consider a polynomial of degree n. F p of x is equal to a0 plus a1 x minus x0 plus a2 x minus x0 into x minus x1. If we go on continue, it is an x minus x0 up to x minus xn minus 1 point less. It is resemblance to that your previous Newton forward. Now we need Newton divided difference. Okay, so we'll take for a1 we'll take x up to x0, for a2 we'll take up to x1, means for an we'll take up to xn minus 1. So now our intention is to know what is a0, what is a1, a2 and so on. We find the coefficients. Okay, so now since this is an interpolating polynomial, you know pxi is equal to fxi by the definition of the interpolating polynomial, is not it? I is equal to here 0, 1, 2 up to n. So this is the definition of the interpolating polynomial. So for x is equal to x0, right? Here px0 is equal to fx0, or in short I write it f0. So f0 means these are all a1 terms, a2, an, so everything is 0. We have only a0, so f0 is my a0. So my a0 value is my f0. I will substitute here. Then next I need to find what is a1. Likewise for your x is equal to x1, what is your f1? Right, what is your fx1? Fx1 is my px1 or my f1. Means here a2 onwards all the terms are 0. Okay, so it is a0 plus a1 into it is x1 minus x0, because x is x1. Similarly for x is equal to x2, here fx2 is your f2 is p of x2, right? It will be here onwards a3 everything will 0. It is a0 plus a1 into x2 minus x0 plus a2 into x2 minus x0 into x2 minus x1. So now let us compute the value of a01 and a2 out of this and continue likewise. So from these what we find? We find here a0 is equal to f0, right? Then one more thing I have to tell you, we are using the forward difference operator, right? The forward difference operator here is delta. One more thing I have to write. So here we will use the forward difference operator. So what is the meaning of the forward difference operator? So the forward difference operator, delta means delta if operated on fx, right? It will give you f of x plus h, next value minus this value, right? Minus this value. So this is the formula for the forward operator, and this entire calculation is based on that. In this sense, if I ask you what is delta of f1, means it is next f2 minus f1. If likewise I ask what is delta of f0, it is next, means f1 minus this value f0. In that way we will compute. I will tell you the computation later on. Now what is my del f0 here? My del f0 will be here f1 minus f0. So this is the value of my f1. So it is here a1 into x1 minus x0. This is cancelled, a0 cancelled. and this is your h, this is your a1h. Okay, so what is the value of a1? So that means your a1 is del f0 divided by your h. Okay, we get a1. Likewise, we want to find your a2. Now likewise, if I ask you what is del f1, it is next means f2 minus f1. Now you subtract f2 minus f1. Here a0 cancel here, and taking a1 term. So this is a1 into here x0 cancelled, x2 minus x1 plus here a2 into x2 minus x0 into x2 minus x1. Okay, so here you see, so x2 minus x1, the gap is h, a1h, and x2 minus x0, the gap is 2h here, it is a2, and this gap is 2h, x0 to x2, it is 2h, and this gap is h. Okay, this gap is h. So now you solve it. Now you see, you substitute the value of a1 here. A1 is here del f0, h cancelled. Okay, now plus it is twice h square a2. Now what is your a2? Okay, and you can write it also 2 factorial. This 2 will be 2 factorial here. So now this implies here a2 will be bringing this to this side, del f1 minus del f0 divided by 2 factorial h square. Okay, so now this will be del of f1 minus del of f0. It is here del square of f0. Okay, del square of f0 by 2 factorial h square. Okay, 2 factorial h square. So therefore here a2 will be del square f0 by 2 factorial h square, right? Likewise here a3 will be del q f0 by 2 factorial h square. Okay, so coming to the forward operator, here del f0 is here f1 minus f0, del f2 f1 means next f2 minus this f1. Likewise here del f0, del square f0 means it is del of next f1 minus del of f0. Likewise. Okay, so while I tell you the properties of the forward differences, I will tell these details. Now we are going to use the all these coefficients here in the formula. Okay, now we use this in this formula. So therefore, what is the interpolating polynomial? Therefore here px will be, here a0 is f0 plus x minus x0, a1 is del f0 by h plus x minus x0 into x minus x1. Here a2 will be del square f0 by 2 factorial h square. And if we go on continue like this, it is x minus x0 into x minus x1 up to the last minus 1, x minus xn minus 1 into del n f0 by factorial n h to the power n. Okay, that means if you continue in this way, here an will be del n f0 by factorial n h to the power n. So in that way we substitute it. So this is the polynomial for Newton forward interpolation. Okay, Newton forward interpolation formula. So this is the formula here. So if a polynomial is asked, find polynomial, then it is fine, we will use this formula. Now if it is find polynomial p of x, if it is find some p of some value, so p of some k, right, then we just want to find a simplified version of this formula, right? For the simplified version of this formula, we will find simplified formula for practical use, Okay, so as I have told you here, what is x2 is x0 plus 2h, because for x2 the gap, 2 gaps are here. So likewise, if I ask you what is x3, it is x0 plus 3h. If I ask you what is xn, it is here x0 plus nh, already n times h are there. Okay, in that way. So in general, we will consider like this. So we put here, let x is equal to x0 plus some, you say some u is another variable, you say like this. Okay, we substitute this. So that means my x minus x0 by h is equal to u. So we want to find this another variable u. So now coming to what is x minus x0. Now this implies my x minus x0 is uh here. Now if I asked what is this implies, what is here x minus x1, I write it x minus x1 is here x0 plus h, is not it? So this is x minus x0 minus h, x minus x0 is here minus h, so this is u minus 1 into h here. Okay, then similarly I find what is x minus x2, it will be x minus x2 will be my x0 plus 2h. So this my x minus x0 is my minus 2h, so this will give me u minus 2 into h. Okay, likewise I need to continue up to x minus xn minus 1, so this will be u minus n minus 1 h, is not it? So this is u minus n plus 1 h. In that way, now we substitute all these things, x minus x0, x minus x1, x minus x2, so on, and my simplified formula will be consequently what will be your formula? It is your uh. So here h cancelled here, it is u minus 1h. Now h square cancelled, it is u into u minus 1. Likewise the formula will be here px is equal to f of 0 plus u del f0 plus next will be u into u minus 1, it is del square f0 by factorial 2. If we go on continue like this, it is u into u minus 1 up to u minus n plus 1. You see this one, it is del n f0 by factorial n. There will be no h here in this calculation. So this is the formula for your practical use. Okay, if it is asked to find p of a particular value, if it is asked you find p of a particular value, right, p of a particular value, x is equal to some k, right, then better we should use this formula. Okay, if it is only asked you find p of x, then if it is only asked to find p of x, we use this formula, right. However we can find it, p of x also will find, but this one will be easy. Okay, so you may use this or you may use this. Okay, so now let us solve some problems. You are asked to find a interpolating polynomial p of 1.4. So here x0 is 1 here, 1.4 is here, and first you see what is the gap. What is the gap here? This gap is 1, this gap is 1. Okay, this h is here 1 here, this gap is 1, so h is equal to here 1 here, h is here 1 here. Now you see what is x0 is my initial point is 1. Now 1.4 is close to this, my 1.4 is close to this initial point, right. So we use Newton forward, right, as x0 is close as 1.4. Coming to the solution, the given data is equispaced and x is equal to 1.4 is close to x0, so we use Newton forward interpolation formula, right. So before that you should know this table. Okay, Newton forward interpolation table you have to know. This is most important. Likewise here divided difference table. So the table is like this. Now coming to the Newton forward interpolation table, you are given x, you are given f. This is my x0, this is x1, this is x2, x3, x4. Okay, so this is my f0, f1, f2, f3, f4. So there are 5 nodes, so we need up to 4th degree polynomial up to del 4th. Now coming to del f, this will be my, we calculate del f0 here. Del f0 means what? f1 minus f0 means just this difference of this 26 minus 10 is my 16 here. Okay, now similarly it will be my del f1, it is simply f2 minus f1. We just find this difference, then we find this difference, it is my del f2. Okay, it is my f3 minus f2, and it is my del f3 up to n minus 1, it is my f4 minus f3. Just to find this difference, but in previous year Newton divided difference, we are dividing again x1 minus x0, but here simply the difference. So this minus this difference here is here 16, and this minus this, the difference here is simply 22, and this minus this here is, the difference here is here 54, right, and this difference here is here 82. Now means we are only bother about this difference. Okay, now next for your del square we find. Now for my del square, the second order, I find just this gap, 22 minus 16. One second, this is actually 32. So this is 32 minus 16, this is 16. Okay, now we have this difference, 54 minus 32. 54 minus 32, it will be my 22. Then I take this difference, 82 minus 54, it is my 28. Okay, so now again for your third order difference we find. For third order difference, this gap, this minus this, it is 22 minus 16, it is here 6. Then 28 minus 22, it is my 6. Only thing I just need to find. Then we find this difference here. This difference is my 0 here. Okay, and for forward we just only this thing, we just only need this thing. Okay, so now what is this value? This value is my del f0. And what is this value? This value is my del square f0. And what is this value? It is my del q f0. Likewise it is my del fourth f0. This thing we need only. Okay, we calculate it and we write this difference here at this middle here. Again we are writing at the middle, but finally we are going to use this f0, del f0, del square f0, del q f0 and del fourth f0. Okay, this thing will be used in the formula. Okay, now before we use the formula, we find let my u is equal to x minus x0 by h. So my given x is, it is asked to find p of 1.4. So my x is 1.4, and what is my x0? x0 is 1 divided by my h is here 1. So this is my 0.4. Okay, so u is my 0.4. Now coming to the necessary formula, right? The necessary formula is, necessary formula for Newton forward interpolation is p of x is equal to f0 plus u del f0 plus u into u minus 1 del square f0 by 2 factorial, and plus u into u minus 1 u minus 2 here del q f0 by factorial 3, and you may just leave it, or if you like you can write it, u minus 1 up to u minus n minus 1, it is bar bracket, or n plus 1, it is here del n f0 by n factorial. Okay, we may just put and leave it here. Now we substitute the values. Now you see the f0 value is 10, x0 value is here 1, del f0 is here 16. Likewise we substitute del square f0 is 16, and we substitute all this thing here. You see from the table I have this information, so now I substitute all this thing here. Okay, so this will give me here f0 is 10 plus u is my 0.4. Now it is my 0.4 into del f0 is 16, then plus my 0.4 into 0.4 minus 1 del square f0 is 16 by 2, then plus my 0.4, it is 0.4 minus 1, 0.4 minus 2 divided by my it is my into 6 by 3 factorial, this into my 6 by 6. Okay, next now is 0, so now I just simplify it, and it will be my 10, it is 6.4 plus, and likewise I calculate it. After calculations it will give me, so let me to calculate. It is my 0.4 into my minus 0.6 into my 8. Then next will be my 0.4 into minus 0.6, and it is my minus of 1.6. This is multiplied with your 1. This is your 1. Okay. So now if I simplify it, I will get it 14.864. Okay. So therefore my f of 1.4 is 14.864. So this is my answer. Now coming to one more example. Now coming to this example, suppose you have a solution. Find a cubic polynomial. Okay, so there are 4 nodes. So 3 degree 3 cubic polynomial. So this gap here is between 0 and 1, 1, 1 and 2, 1. So this is equispaced, right? So we first compute the forward table, Newton forward table. So actually this table is called considered the difference table. Okay, the difference table. This table will also work for your backward. This table will also work for your forward. So here you are given x, you are given f. So x is 0, 1, 2, 3. Here f is 1, 2 and 110. So now we calculate del f. First order del f is this minus this is my 1, and this minus this is my minus 1. This minus this is my 9. Then we calculate del square f. Write it here. This minus this, it is my minus 2, and this minus this, 9 minus of minus 1 is my 10. Then I calculate my del qf. Del qf is this minus this, it is 10 minus minus 2 is my 12. Okay, so now this is my f0, this is my del f0, this is my del square f0, and this is my del qf0. So actually these things are needed while we use the formula. And what is my h here? You see my h, this gap is my 1 here. With this information I will now compute the formula. The Newton forward interpolation formula is given by f of f p of x is equal to f0 plus x minus x0 del f0 by h plus x minus x0 into x minus x1 del square f0 by h square factorial 2. Likewise, and I put just dot. So now I simplify it. So now if I simply simplify it, my f0 is 1, f0 is my 1 plus x minus x0 x into del f0 is 1 only, then plus x minus x0 into x minus x1, and my del square f0 is minus 2 by here h square, means only 2 factorial. Then plus next will be x minus 0, x minus 1 up to this x minus 2, and del q f0 will be 12 divided by 1q into factorial 3. And if I simplify it, it is 1 plus x. Now if I simplify it, it will give me 2x cube minus 7x square plus 6x plus 1. So this is the interpolating polynomial, or f of x is equal to this. Okay, so this is the desired answer. Now if I want to use the formula for the practical use, as I have told you, it will be like this. We can also use that formula. You see here, x0 is equal to 0, u is equal to x minus x0 by h. Okay, so this is x minus 0 by 1 is my x. So here it will not be complicated. Okay, otherwise if some complicated thing will there, then it may be lengthy. This previous formula will work. So what is my formula here? Now p of x is equal to f0 plus u del f0 plus u into u minus 1 del square f0 by factorial 2 plus u into u minus 1 into u minus 2, it is del q f0 by factorial 3. We leave it here. Okay, so that means my f0 is my 1 plus u is my x my del f0 is 1 plus x into x minus 1, here del square f0 is minus 2 by factorial 2, then plus same thing here, it is same as this, it is plus u into u is my x into x minus 1 into x minus 2 del q f0 is here 12 by factorial 3 is here 6, and you see it is same as this. Okay, now here instead of x0 is 0, if something else, then this will be rather complicated, and instead of h it is 1, it is something else, then it will be complicated. So here this formula will find then. So now this will be, if you simplify it, it is 2x cube minus 7x square plus 6x plus 1. Now if it is asked also find p of minus 1, or also find p of here 0.5. if it is asked also p of find suppose 2.5, or you find p of some 4, it is asked. You see, now this 2.5 is close to this end point, 4 is also close to the end point. In this case we can use Newton backward interpolation formula. But here you see minus 1 is close to your 0 initial point, and 0.5 is close to 0. So here we use Newton forward interpolation. Okay, but in polynomial interpolation, if we directly substitute here, then there will be no harm. If I directly substitute here, what is p of minus 1 and what is my p of 0.5, okay, and if I find here p of suppose 2.5 or 2.4, p of 2.4, 2.5 or p of 4, p of 2.5 or p of 4, we can directly substitute here. Okay, we can directly substitute over here, but usually we should use Newton backward here, but also this will work because it is a polynomial. No error, no much error will be there. Okay, otherwise it needs this Newton backward. Now coming to one more example, coming to one more question. The following table gives the marks secured by certain number of students, right? Find from the following data, estimate the number of students who obtained the marks between 40 and 45. So information is given, marks scored 30 to 40, the number of student is 31 here. Marks scored 40 to 50 is 42. Likewise 50 to 60 it is 51, it is 35, and it is 31, this is given. And you are asked to find the marks between 40 and 45. Okay, between 40 and 45. So means here it is here 40 and 45. So we have to see. A converted table here. Okay, so now while we solve it, I can say it is less than 40, marks scored less than 40, marks scored less than 50. In that way I can prepare a cumulative table. So here for this I can add this less than 50. So in that way I prepare a cumulative table. First we prepare a cumulative table as follows, right? So we write it here, marks less than x, marks less than, let it is my x, number of students, it is my f of x. So here less than 40, and it is less than 50, it is less than 60, it is less than 70, it is less than 80. So less than 40 is 31, less than 50 is 31 plus 42, it is 73, less than 60 means sum of these three. Okay, this will 124, and this will again we add this first 4, it will give me 159, and if I add all it will give me 190. So this is my modified table. Okay, this is my modified table. So actually we are interested to find the marks scored between 40 and 45, is not it? 40 and 45. 40 and 45 means it is my P of 45 minus P of 40. So student scored mark less than 45. minus student scored marks less than 40, then student scored marks within this. Now here this 45 is here close to this initial point, it is my x0, so I use here Newton forward interpolation here, and here it is directly given, and it is directly given my 31. Okay, otherwise if it is directly not known, we have to again use a numerical method. So now my interest is to find P of 45. So I compute the difference table as follows. So I just tabulate it. This is x and this is f. For my first order del f, it is my 73 minus 31, it is 42. Then my 124 minus 73, 51, and likewise it is my 35 and it is my 31. Then I have my second order del square f, it is 51 minus 42 is 9, then 35 minus 51 is minus 16, then 31 minus 35 is minus 4. Then my del qf is minus 16 minus 9 minus 25, it is minus 4 minus 16, 12. Then my del fourth f 12 minus 25 minus of minus 25 is 37. So actually we need this. It is my del f0, it is my del square f0, it is my del q f0, it is my del fourth f0, and it is my f0, and it is my x0. So this thing we need to use the forward formula. For backward we need this. Okay, we will see later on for Newton backward, but we are using this for your Newton forward. Okay, for Newton forward we are going to use this. So now what is my u? Let my u is equal to x minus x0 by h. What is h here? What is the gap here? The gap is 10. So my h is my 10, h is my 10, and x0 is my 40, x is my 45. So this is my 45 minus 40 divided by 10. It is here 5 by 10 is half, 0.5. Okay, so this is my u. So my Newton forward interpolation formula here, P of x is equal to f0 plus u del f0 plus u into u minus 1 del square f0 by factorial 2 plus u minus 1 u minus 2 del q f0 by factorial 3. Then the last one u minus 1 u minus 2 u minus 3, it is del q f0 by factorial 4. So now I substitute everything. f0 is my 31 and del f0 is my 42 and del square f0 my 9 and my del q f0 is my minus 25, del fourth f0 is my del fourth f0 is my 37, and u is my 0.5. okay, u is my 0.5. I substitute all these things and it will give me 31 plus 21 plus 21, it is minus 1.125 minus 1.5625 minus 1.4453. If you add it, it will give me 47.87. So this is my rounded to next, because number of students, you say it is 48. okay, 48 say, but this number of students scored mark. Now my desired answer will be P of 45 minus P of 40, right? So the number of students scored mark between 40 and 45 is, so the number of students scored marks between 40 and 45 is my P of 45 minus P of 40. As we see, this is my 48 and this is my originally given 31 and the number of student is my 17. So this is my answer. So in my upcoming lecture, I shall discuss the Newton forward interpolation, Newton backward interpolation formula. Okay. So now the forward interpolation, I hope this forward interpolation is now clear to all of you. Now if you find this lecture is helpful and interesting, please like and subscribe to this channel, so it will boost my motivation to upload the subsequent lectures for your benefits. So thank you all. Have a nice day. Let us close this lecture here. Once again, I thank you all for patience listening.